Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be looking at finding the equation of parallel lines. So first of all, a quick recap on the equation just generally for any straight line. It's in the format of y equals mx plus c. If you want to go back through this, then I will link down below the full video. But as you can see, we've got m, so the number in front of x represents the gradient, so how steep the line is. And then c represents the y-intercept, so where it crosses the y-axis. Now that is relevant to parallel lines because they are obviously straight lines, but we also need to know what parallel means just generally. So if you're not sure what parallel means, it's basically, in the context of lines, that we've got the same distance continuously between the lines, or in other words, parallel lines never meet. So you can see between these two blue lines, they are the same distance apart the whole way through. They're never going to cross and they're never going to get further away from each other. It's just the same distance apart. Back to how that relates to our equation of straight lines. The key piece of information that you just need to remember for GCSE Maths is that if two lines are parallel, it means they have the same gradient. So the number in front of the x has to be exactly the same for both lines. So whether they're both positive, whether they're both negative, the same number, and also, more importantly, when you've got y as a subject. That makes them parallel, because if they can't cross each other, they can't get closer or further away, they just continuously stay at the same distance from each other, then effectively we're saying that the steepness of the lines is exactly the same, aren't we? And as we said, steepness is the gradient. So as long as you're happy with how the equation of straight lines works, and as I said, if you want to go back and check out that video first before you do this one, go ahead, I will link it in the description. But as long as you're happy with straight line graphs and equations just generally, the only additional piece of information here is that they have the same gradient. That's it. Just remember that one key piece of information. So now let's actually look at some of the questions. So starting with, write down the equation of the line parallel to y equals 2x plus 1 and passes through 0 minus 5. Now we mentioned that they have the same gradient. The one thing that they don't necessarily have the same is the plus c. So the y-intercept will be different, but the gradient will be the same. So write down the equation of the line. So we know it's going to be y equals mx plus c because it's a straight line. I need to figure out the gradient and I need to figure out the y-intercept. The easiest thing is the gradient because we know it's parallel, which means I just have to look at what the gradient of the other line is. The other line, the gradient is 2. Because it's parallel, that means they have the same gradient. So I can now replace this with 2 as well. And then I obviously need to work out, okay, yeah, they've got the same gradient, but it doesn't necessarily mean that they are in the same place on the grid, if you imagine it like that. It might be somewhere else on the grid. So what is my plus c, or my y-intercept, for this other line? Well, that's why they've given us another set of coordinates. If you remember from the video where we looked at how to find the equation of any straight line, we need to find the gradient first, and then, in order to find the y-intercept, if you can't obviously see it in front of you, you normally have to take a set of coordinates and substitute them in. Now yes, you could substitute in 0 for x and minus 5 for y, but do pay attention to these coordinates particularly. Sometimes they give you just random coordinates, in which case yes, sub them in, work out what c is. But where x is 0, that is the y-axis, isn't it? So for this one, that's why they've said write down, because it's a little bit easier. For this one, they've just told me that the y-intercept is minus 5, it is negative 5, because where x is 0, that is the y-axis, isn't it? So I can just straight away write down that my y-intercept is minus 5. I don't have to substitute in those numbers if I don't want to. If you can pick up on the fact that the specific coordinates they've given you are actually, in fact, on the y-axis, you don't need to substitute them in. If you haven't picked up on that, or if they obviously don't happen to be coordinates on the y-axis, then you should substitute them in to find the plus c. So the equation of the line that is parallel to y equals 2x plus 1 is y equals 2x minus 5 in this particular case, because they told us it passes through 0 minus 5. So let's try a couple more so you can start to pick up on the pattern of what we're doing. Now we've got find the equation of the line parallel to 2y plus x equals 5 and passes through 10 minus 2. Hopefully you can see the difference in the wording here as well. originally, for the first question, if we go back, it says write down. Write down. Whenever they say write down, it tends to be a 1 mark question, maybe 2 maximum, but there's not really much you have to figure out. You can see here we just copied the 2, we copied the -5. Pretty straightforward. But if it says find or work out, then it's normally hinting at there's a little bit more work to do. So the first thing I need to consider is that, yes, I have got an equation of a straight line here. I can see that it's linear. But what I don't have is the format where y is the subject. So if it's not in the correct format where y is the subject, I can't just copy whatever's in front of the x. That wouldn't be the correct gradient because it's not rearranged properly. So what I will have to do firstly to find the gradient is rearrange the equation to get it in the form y equals mx plus c, and then I can copy it. So if I rewrite it here, 2y plus x equals 5, I need to make y the subject, so I'm going to take away the x. Now you can put it in front or behind the 5, but I'm going to put it in front just because that's the format that we have, isn't it? Y equals mx plus c, so I'm just going to put the x at the front. And then I do need to actually divide by 2 as well, because I don't want 2y, I need just 1y. So when I divide by 2, that actually gives me -1/2 x plus 5 over 2, or obviously that would be 2.5. That's the equation of the other line, of the original line, isn't it? So now I can have a look and say, what's the gradient? It's -1/2. Because the 2 lines are parallel, my new line will also be -1/2x, so -1/2x, and then I'm just missing the plus c for my new line. So you can almost go through and tick off the information. I've used this information. The only other information in the question I haven't used is the coordinates 10 minus 2. Whereas in the previous question I just copied the y coordinate, didn't I? I can't do that here because it's not on the y-axis, is it? You can see it's where x is 10, y is -2. That's just like a random coordinate. So this is the case where I would have to substitute in both numbers in order to solve to find c. And also make sure that you substitute them in correctly, because it can be quite easy to think, well, y comes first here. I'll just put the 10 first, but it's not. It's the other way around, isn't it? X is 10, y is -2. So -2 first, and then -1/2 multiplied by 10 plus c. Do you see how the only thing missing, the only letter that I don't know is c now, isn't it? And that's the thing I want to find out. So at this point, it's just like normal equations. Just solve it. -1/2 times 10 would be -5. And then obviously add the 5, so I get 3. So my y-intercept is 3. So now let's write the whole equation of the line out. Just going to move everything over so we've got space. Therefore, this is my answer. Y is equal to, we said that the gradient is -1/2 x, and then the y-intercept is at 3, so plus 3. So this one, we had a little bit more work to do, didn't we? We had a few more steps in order to figure some things out. It wasn't quite as obvious as the first question. Okay, this one is only different because now we can see one of the lines drawn for us. We've not been actually given the equation written down. So find the equation of the line parallel to line L, which is the one drawn here, and passes through for -1. So we need to know, not necessarily the whole equation of line L, I mean you could obviously work it out, but just the gradient really, don't we? Because we know that the gradient of line L and the gradient of the line that I'm trying to find out is the same. So all I need to do is use this grid to work out the gradient. Now again, if you have seen the other video on finding the gradient of a straight line, you will know that there's a few different ways to do this. The way that I might do it is just choosing 2 solid coordinates. So what I mean by that is ones where they go through whole numbers. So you can see here, it goes through at -2, 1, that's a whole number, isn't it? And then the next one would probably be maybe here, 0, -4. Then we have to work out the change in y over the change in x. So the change in y, you can see, is going down, isn't it? And then x obviously along to the right. So the change in y, we've gone from 1 to -4, so that's -5, because it's going down. And then the change in x is +2, because it's going in the correct direction. So therefore the gradient of line L is the change in y, which is -5, over change in x, which is 2. So that's effectively -5 over 2, or -2.5, isn't it? So now I know the gradient of line L is negative 5/2, which means the gradient of the line that I want to find out is also negative 5/2. So if I write it in my y equals mx plus c, the only thing missing for my new line is the plus c. So I've used the information from the grid. I also now have this set of coordinates, which if you have a look at it again, they do not lie on the x-axis. So I now have to sub them into this equation in order to find out the plus c, which is the y-intercept, just as we did in the previous question. So again, just be really careful that you do sub the correct coordinates in, because it can be easy to put the x1 as y, because they both come first, and vice versa. So we've got y first, which is negative 1, equals to minus 5/2, and then instead of x, we've now got 4, so multiply by 4 plus c. That's just an equation that I can now solve. I want to find what c is. So if you multiply this bit, you should get negative 10. So we've got minus 1 is equal to minus 10 plus c, and obviously then just move it across. So that gives me 9 for c, positive 9. So now I know the y-intercept, I can just write my answer together. The whole equation would be y is equal to the gradient, which is minus 5/2 or minus 2.5, x plus c plus the y-intercept, which is positive 9. So there's my final answer. My new line that's parallel would obviously be just as steep as line L, so it would be this kind of angle of a line, but it would cross somewhere up here, so where it's 9, somewhere up here is where it would cross, instead of negative 4 for line L. And that's the only difference, so they are the same steepness, they're just in a different position on the grid. Okay, another format now. We've got two sets of coordinates instead of either a grid or instead of being given an equation in the first place. So line L passes through 1, minus 2 and 10, 5. Find the equation of the line parallel to line L and passes through the origin. So the overall structure is the same, isn't it? We first need to find out the gradient of the line L in this case, and then copy it. So how do I find the gradient of line L? Well, we've just literally said, haven't we? Change in y over change in x. Now, when there's coordinates involved, when you're not just counting the squares on a grid, you might want to use this formula. Change in y, so one of the y coordinates minus the other y coordinate, over the change in x. So one of the x coordinates over the other x coordinate. Now that looks quite complicated, but you can always label it if you like this. So let's say that this is my second lot of coordinates, this is my first lot. It doesn't matter which way around you put them in terms of these sets of coordinates, as long as vertically you see how they match up with the original pair. So I would do 5 minus, don't forget any negatives, you might have a double negative in that case. 5 take away negative 2, and then the x's would be 10 take away 1. Obviously, if it's a calculator question, you can just type that in. Otherwise, you should get 7/9. So the gradient of line L is 7/9. Because our new line is parallel to line L, it means it has the same gradient. So now, for my new line, I've got y equals 7/9 x, and then what is my y-intercept, the plus c? Well, that's now the piece of information here, isn't it? It hasn't given us literally a set of coordinates, but it has said that the line passes through the origin. I just included this just to make sure you knew what the origin is referring to. If you have a grid, the origin is just 0, 0, basically. We're just saying at 0, 0. Now, you could also substitute those two coordinates in if you wanted to check, but as we keep saying, whenever x is 0, that is the y-axis, isn't it? So that means that the y-intercept is actually 0. Now, I obviously wouldn't write plus 0 because that's kind of pointless, isn't it? So just leave it blank. It's not that there isn't a y-intercept. There will always be a y-intercept. It's just that the y-intercept is at 0. So that would be my equation there. Y equals 7/9 x. Okay, so we've seen a variety of different ways they could present the question, but we've effectively done more or less the same thing. Work out the gradient first, and then work out the y-intercept. This question, though, is slightly different. So we've been told that the equation of line A is y equals 3/2x plus 1, and the equation of line B is 4y minus 6x equals 7. And we are asked to show that these two lines are parallel. So how do we show that two lines are parallel? Well, it's again all back to the gradient. Show that they have the same gradient. And normally the way that I would show the gradient is by having this format where y is the subject. So I can see that the gradient of line A is 3/2. Or in other words, 1.5. I can't look currently and compare directly the gradient for line B because it's not in the same format, is it? I don't have y as the subject, so obviously you can see currently the coefficient of x, the number in front of the x, is -6. That's not necessarily the gradient though, because we need to have it as y equals. So what I actually need to do here is rearrange equation B so that y is the subject. So to make y the subject, I'm going to add the 6x. So I've got 6x plus 7, and then divide by 4. So you've got effectively 6/4, which if you were to work that out would give you simplified 3/2. So I've got 3/2x plus and then 7/4. As we keep saying, the y-intercept will obviously be different. That doesn't really matter. We're just focusing on the gradients. So the gradient for line B is also, you can see, 3/2. And then I would probably make a little conclusion, something like same gradient. Therefore, that means that they are parallel. This is normally maybe a 2-mark question, but it's quite easy. Just work out both gradients so that you can see them in the same format. Hopefully they should be the same number, literally. Also, same in terms of if they are positive or negative. And then you say same gradient, therefore parallel. So really easy question, that one. So that is pretty much everything on parallel lines. The key takeaway is that they have the same gradient. That's all you really need to know. The next video is finding the equation of perpendicular lines, but this is specifically for higher tier students. So if you are a foundation tier student, you don't necessarily need to worry about the next video. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.